in this video, we're going to be looking at solving linear inequalities. It's going to work very similar to the previous videos where we were solving equations. The only difference is instead of having equal signs, you're going to have one of these inequalities that you see highlighted right now. The two questions we're going to have to answer, parentheses or brackets, and then which direction is shade. So I made a chart for you guys. If you have less than, you're going to shade left, and it's going to be a parenthesis. Same thing with less than or equal to, shade left, but with a bracket, a closed interval, and then you can see the same thing for greater than or equal to. You will shade to the right and then either have a bracket or a parenthesis based on the specific inequality. Something to note that the bar underneath the bracket can be a reminder that for greater than or equal to or less than or equal to, you are going to have brackets on your graph. This only works if the variable is written first. So I will always move the variables over to the left-hand side. That way my graphing is a little bit easier than moving them to the right and then flipping it. Also, one more thing to note, that if you multiply or divide by a negative number, make sure you flip the direction of the sign. So if it was open to the left, you're going to make it open to the right, and if it was open to the right, you are going to make it open to the left. Your steps are the same for solving linear inequalities, and you can find those on the blank notes. You're going to do parentheses first. Once the parentheses are done, combine up like terms. Once those are done, move the variables to move both variables to one side. Constant, coefficient. So those are going to be your same steps that we used before. So here is my first example. So example 1, the first step says to graph x greater than or equal to -4. I wrote a hint off to write in interval notation first. Hawks did not ask for interval notation for this specific one, but I actually am going to go through the interval and the graph in both of these, even though it only said to graph. So I graph first, even though the hint says to write interval notation first. It makes more sense for me to graph. Here is my inequality, greater than or equal to. So if we use the chart that was just on the screen, greater than or equal to means that it's going to have a bracket because it's got that bar. And so the bracket's going to go on -4. And then I'm going to shade to the right. I shade with zigzag so that you can see it over top of the line. So there is my graph. The interval notation for this, it didn't ask for it, but interval notation is written from left to right. And so if I was standing on this line and I was walking to the left, the very first number that I would come to is -4 with a bracket. And then as I continued to walk, I would get to infinity. Now, infinity is always going to get a parenthesis because you can never actually arrive at infinity. It can't be closed, can't be contained. Infinity is always going to get a parenthesis. You are also always going to write from left to right in interval notation, which means sometimes infinity will be first and sometimes it will be second. Negative infinity will always come first. Positive infinity will always come second. But if you remember the order from left to right, based off the graph, you'll be good to go. Step 2 then says, what kind of interval is this? Well, open intervals. This is multiple choice in Hawks, but as a quick review, open intervals are 2 parentheses, closed intervals are 2 brackets, and then any combination of the two would be a half open interval. So this one, I've got a bracket and then a parenthesis, so I'm going to be half open interval. Okay, example 2 says to write an interval notation and then graph the solution set. So I'm going to go through my same list of steps as equations. Step 1 is parentheses. Step 2 is do you have like terms? Step 3, variable on both sides. 4, constant. 5, coefficients. So here, no parentheses, no like terms. So I do have a variable on both sides. I always am going to move the variable to the right, or sorry, move the variable to the left. And that's just for inequalities. It's because it's going to make your life a little bit easier when you graph. So I'm going to add 3x to both sides, which those are going to cancel. I'm left with negative 2x minus 3 less than or equal to negative 5. Do I have a constant? Yes, so I'm going to add the 3 to both sides. Those will cancel. And then simplify. Divide by negative 2, divide by negative 2. Now something that we talked about on the very first part of this video was that if you multiply or divide by a negative number, you have to flip the inequality. So that thing is going to turn because I divided by that negative 2. So I flip the inequality. So now I have x is greater than 1. I do the graph first and then go back to interval notation. So for the graph, I'm going to put a bracket on 1. It's just going to be between 0 and 2. And then because I am greater than, I'm going to shade to the right. And so there would be my graph. And then getting interval notation from that. If I were walking on the graph from left to right, so I'd be walking this direction, the very first number that I would come to would be 1 with a bracket. And then as I continued to walk on the graph, I would eventually get to infinity, which infinity just means it keeps going on and on and on, getting bigger and bigger and bigger. And again, infinity gets a parenthesis, and 1 got a bracket. And so here's my last example. Write in interval notation and graph the solution set. So going down my list, do I have parentheses? Yes. So the first thing I need to do is distribute. Have negative 8x, and then distribute the negative 2 to get negative 6. Carry everything down. From here, I'm going to add my variables to the left. So I'm going to add 2x, add 2x. Those will cancel, and I'll be left with negative 6x minus 6 is less than or equal to negative 24. So I'm going to continue solving, move over the coefficient. So I'm going to add 6 to both sides. Those will cancel, and I'll have negative 6x is less than or equal to negative 18. And then I'm going to divide by negative 6, divide by negative 6. Those will cancel, and I'll be left with x. Now, I'll be left with a positive 3 over there. Because I divided by a negative number, I'm going to flip the inequality. And again, that only happened because I divided by that negative 6. So I'm left with x greater than or equal to 3. So, again, I graph first, and then I do my interval notation because I'm more of a concrete thinker. I'm going to put a bracket on 3 because it's greater than or equal to, and then I am shading to the right. So there's going to be my bracket, shading to the right all the way. And so my interval notation, if I was standing on the graph and I was walking from left to right, so the first thing that I would come to is 3 with a bracket, and then as I continued walking, I would go on forever to infinity, which always gets a parenthesis. And so that would be my interval notation, and then down below would be my graph.